Another interesting concept of the moment is the couple moment. Couple moment is the tendency of the body to rotate when the body is being subjected to couple forces. Couple tu maksudnya berpasangan kan? It involve two person, not three, not four. If it involve more than two person, then itu bukan couple namanya, itu curang. Okay? Jangan berani-berani kamu nak buat. So anyway, couple force involve two forces which have the same magnitude and it is positioned parallel to one another. So these forces have the opposite direction and it is separated by a perpendicular distance. So the moment produced by the couple force is what we call the couple moment. Okay, simple as that. So what is so cool about the application of couple moment is that it can simplify many engineering mechanics calculations. Okay, now let's say we have a pair of forces with the same magnitude but with different direction. So that pair of force is what we call the couple force. And this couple force creates a tendency to create a couple moment. So the direction of the couple moment is as shown. Okay, so you can identify the axis of the couple moment by using the right hand rule. Okay, buat macam jari good macam tu, and then the direction of your thumb, which is perpendicular to the plane of the force, would be the direction of the moment axis. Okay, itu axis dia sahaja. So how about the moment? Remember, moment is about rotation kan? So the direction of the rotation tu depends on the other four fingers, which is jari telunjuk, jari hantu, jari manis, jari kelingking punya direction tu. So that is the direction of your moment. Okay, the cool thing about the couple moment is that it can simplify your engineering mechanics calculation, whereby if we want to consider the scalar formulation, you can get the magnitude of your moment by multiplying the value of the couple force and then multiply with D. D in this case bukan distance to the rotation point, but simply it is the distance between the couple force. It is the perpendicular distance between the couple force. So actually daripada dua equation, you can simplify the equation to become only one very simple equation. So if you look in this example, it asks you to find the resultant moment of all the forces acting on the plate. So sekali imbas you tengok, alamak, banyaknya dia punya forces. So it's going to be a very complicated calculation. Tapi remember, the couple moment actually simplifies your equation in so many ways. First, kita identify ada berapa banyak couple forces in the system. Okay, so this is one couple forces, same magnitude, different direction. This is the second couple forces, same magnitude, different direction, and this is the third couple forces which have the same magnitude but with opposite direction. Okay, so simply kita ada tiga combination of couple forces. So we can use the scalar equation whereby moment can be attained by multiplying the magnitude of the couple force with the distance. The distance in this formula is the perpendicular distance between the couple forces. Okay, jom kira the resultant moment. So the first moment is the F1 D1, and then the second moment is for the F2 multiplied with T2, and the third moment is F3 multiplied with T3. So first, if you look at the F1 punya force, it will create a tendency to rotate like this. Okay, follow the direction of the couple tu. So kalau tengok direction of rotation is clockwise. So if we assume the counterclockwise to be positive, then kalau direction of the couple forces is clockwise, then the magnitude of the moment would be negative. Now let's look at the second force, the 450 Newton punya force tu. So if you create an imaginary circle to follow the trajectory of the couple force, it will create a tendency to rotate in counterclockwise direction. So kalau counterclockwise, then the magnitude of the moment will become positive. And then the third force, the third couple force, again you create the imaginary circle and it will create a kind of clockwise kind of rotation. So again, kalau clockwise, it would be negative. Okay, sekarang simply substitute all the values into our equation. The magnitude of the couple force one is 200 Newton. So you just put 200 Newton over there. Jangan lupa negatif dekat depan tu. And the distance between the first couple force is 1.2 meter. Okay, just letak 1.2 meter. The second force, it have a magnitude of 450 Newton. And the distance of the second force is 0.9 meter. And finally, the third couple force have a magnitude of 300 Newton. And the perpendicular distance of the force is 1.5 meters. So use the wonder of your calculator and you will get a corresponding resultant moment to be negative 285 and the unit is Newton meter. So this expression can also be rewritten as 285 Newton meter. But what is the direction? Kalau negative, the direction is clockwise direction. Please include the direction in your final answer. Now let's look at the second example. So in this example, if you notice, the direction of force tu dah mula sengit-bengit. Okay, kalau kita ikut the formula of couple moment, whereby we need to identify what is the perpendicular distance between the couple force, macam mana you nak kira the distance between these two force bila dia dah sengit-bengit macam ni? So the calculation becomes kind of complicated for this particular force direction. So in order to ease your calculation, you can actually resolve the force into two directions, which is the x and the y direction. For the couple force pun, you can resolve it into the x and y direction as well. Okay, the magnitude along the x and y direction can be resolved using the trigonometric punya function. So, the magnitude of force along x direction can be computed by using 600 cos 30. Accordingly, magnitude along the y direction is equivalent to 600 sin 30. The same goes to the couple forces as well. Okay, based on the new direction of the force, so there is one couple force along the x direction and there's another couple force along the y direction. So the calculation of the resultant moment becomes so much simpler. You all can use the same formula, the same technique as the previous example. So I'm going to fast forward this particular section so that our video won't be too long. So you should get the resulting moment to be 43.923 and the unit is Newton meter. So the magnitude is positive, so it means the direction of the resultant moment would be in counterclockwise direction. Okay, dah siap? Okay, sometimes scalar formulation alone is not enough to solve complex engineering problems. So sometimes you have to use a vector formulation. So kalau sebelum ni, let's say you have a couple forces with the same magnitude acting on different direction, and then if this is given O as the rotation point. Okay, let's use this position vector from point O to one point called point A along the F line. So we are going to call this position vector RA, and then there's another position vector from the rotation point O to one point along the second force punya line too, and let's call this RB. Based on the previous vector formulation, you can get the Cartesian vector of the moment by using cross product, whereby position vector cross product with the force vector. So looking at this system, there are two forces exist. Okay, force, let's call this force 1 and let's call this force 2. So in order for you to get the resultant moment, you have to cross product RA with F1 plus with the position vector B cross product with F2. So this becomes a little bit macam tricky lah, and the calculation process becomes a bit longer. Okay, when your calculation involve a couple moment or a couple force, then you can actually simplify the vector equation to become the cross product of R with F. The F is the vector of the couple force, and R this time around is the position vector from one line of force to the couple punya line. Okay, like this as shown. Okay, so instead of using two position vector and two force vector, you can actually simplify the calculation of moment vector just by using this equation. So in a conclusion, by using a couple moment kind of formula, your calculation becomes so much simpler. Okay, so in this example, given a pair of couple force with a magnitude of 25 Newton, based from the previous formula, we can calculate the vector of the moment by using the R vector cross product with the F vector, whereby the R vector is the position vector connecting between the couple moment. So in this case, let us first find the coordinate A first. So coordinate A would be 0 in the x direction, and in the y direction, if you look carefully, the magnitude be 0.8, and along the z direction, tak ada arah kan, so it becomes 0. So the unit is in meter. So correspondingly, you also need to look for the coordinate B. So coordinate B, if you look carefully, along the x direction, would be this distance, which you can calculate by using 0.6 cos 30. So it's like a trigonometric triangle over there, kan? And then the y coordinate would be, kalau tengok carefully, would be 0.8 meter lah. And the z coordinate would be from this point to this point, by which you can calculate using the trigonometric relationship of 0.6 sine 30. Don't forget the negative sign because it's pointed downwards. Now you can convert this coordinate into an equivalent position vector, whereby position vector of A or RA is equivalent to, kalau tengok dekat sini, is only 0.8 in the direction of J. So yang lain semua kosong, we can just ignore it, and the unit would be in meter. So accordingly, you can also find the position vector for point B or RB, whereby it would be 0.6 cos 30 in the direction of I plus 0.8 in the direction of J minus 0.6 sin 30 in the direction of K. And again, the unit will be in meter. Okay, now that we have the position vector of A and B, we can find the position vector connecting point A and B by using the formula of RAB is equivalent to RB minus with RA. So this is quite straightforward from here onwards. So you try to solve this, and the answer will be as shown. Okay, so R is settled. The next thing we need to look for is the force vector. So kalau you tengok force vector, the magnitude is 25 Newton and it moves actually in the direction of Z only. So again, you can use jalan kerja panjang, force vector equivalent to magnitude of force darab dengan unit vector, yada yada. Tapi kalau tengok dekat sini, it's quite straightforward, whereby the vector of the force can simply be rewritten as 25 K hat because it only moves in the direction of Z sahaja. Okay, so IJ tak mempengaruhi dia punya displacement. Okay, so this is the force vector. Now all the information is complete. You can calculate the moment vector by using the formula of position vector connecting between the couple forces cross product with the F. So if you recall, kalau cross product ni is much convenient if you rewrite it in a metric form, whereby the first layer tu is the IJK direction, and then the second layer would be the position vector connecting between the couple forces, which is this one. Okay, so you rewrite it again, and the third layer would be the magnitude of the force vector over here. So you try to solve the cross product operation on your own, yada yada yada, and you will get a corresponding moment vector to be negative 12.99 in the direction of J, and the unit is Newton meter. So if you want to check whether your answer is correct or not, you go back to the image given and then you draw an imaginary line connecting between the couple forces. Okay, follow the direction of the couple forces. So if you look at my sketch, this is the direction of the moment. So now use your right hand punya rule tu, okay, the four fingers to follow the direction of the rotation moment. Okay, my hand look very funny here, but I hope you get the point. And the thumb is pointed towards the negative y direction. So in a way, your answer is negative 12.99 in the direction of J. So your answer match with the right hand rule. equivalent couple means that the magnitude of the couple moment is the same walaupun the magnitude of the forces are different. So, for example, looking at the image on the left, if you want to calculate the couple moment of this particular case using formula F multiplied with T, the force exerted is 30 Newton, the couple force, and the perpendicular distance between the couple is 0.4 meter. So you will get a corresponding value of 1.2 Newton meter. So on the other hand, the picture on the right shows that the couple force is 10 Newton higher, which is 14 Newton, but the distance between the couple force is shorter, which is 0.3 meter. But if you calculate the couple moment, you will also get the same magnitude of 1.2 Newton meter. So these two cases are known as equivalent couple. Tapi anyway, apa yang you boleh nampak from these two different cases is that the higher the perpendicular distance between the couple forces, the lower force are required to generate the same amount of moment. So that is why kalau macam if you are to design a wheel or a steering wheel, the bigger the diameter of the wheel, the less force are required to turn it around. Okay, similar with the force punya concept, the resultant moment can also be calculated by summing up all the cross product between the R and the F. So this is quite straightforward lah sebenarnya. Okay, let's look at this example. In this example, you need to find the resultant moment of all the forces exist here. So first step, identify how many couple forces are there. So there is one couple forces over here and there's another couple forces over here. So if you look at the information given, you can actually perform Scalar formulation to find the moment of each couple. Okay, so let's look at this combination of couple first. Okay, so the formula to find the moment is equivalent to F1 multiplied with T1. So the couple force is 150 Newton. The perpendicular distance between the force is 0.4 meter. So the corresponding magnitude for this couple force would be 60 Newton meter. Okay, so macam mana kita nak tahu the direction of the moment? So again, you draw an imaginary circle connecting between the couple forces. So if this is the direction of the moment, use your right hand rule. Okay, follow dia punya trajectory of the circle and the direction of the moment axis would be in this direction. So kalau you notice, direction dia is always perpendicular to the force punya plane. So the vector of M1 only exists in the x direction only, not y, not z, only x direction. So you can rewrite this in a vector form whereby the vector of moment 1 will be equivalent to 60I Newton meter. Positive ke negative? Positive, because the direction is pointed in the positive x punya direction. Okay, now let's solve for the second moment. In the second combination of the couple force, again similarly we use the formula F2D2. So the couple force F2 is 125 Newton and the distance between the couple force is 0.3 meter. Use your calculator and you'll get a corresponding magnitude of 37.5 Newton meter. Okay, now look very carefully. Kita create an imaginary rotation connecting between the couple force like this. So use your right hand rule, okay, and then your thumb will be pointed on this direction dan dia berada di plane YZ sahaja. Okay, look very carefully. It will be exactly in the middle. Okay, so if this is the direction of the moment, then you can calculate the vector of the moment by using the trigonometric function, whereby the moment yang initially sengit tu in the YZ direction can be resolved or being split into the Y and the Z direction. Okay, so the magnitude of this particular moment is 37.5 Newton meter. If I were to rewrite the moment in a vector form, so it will be M2 in the Y direction. So this would be the direction of J plus with M2 in the Z direction, and this would be the magnitude in the direction of K. Using the trigonometric function, the moment along the y direction can be calculated using 37.5 cos theta, if this is your theta lah, in the direction of j, plus with m2 in the z direction is 37.5 sin theta, okay, in the direction of k. So, if I were to keluarkan this little triangle over here, okay, there are the 3, 4 and the hypotenuse is 5, then this angle would be theta. So therefore, I can actually rewrite my equation whereby 37.5 and then cos theta in this case would be 3 over 5, sebelahan per hypotenuse, okay? And then for the next expression is 37.5 sin theta. Sin theta will be equivalent to tentangan per hypotenuse, which is 4 over 5. You can use your calculator and you will get the vector of the second moment to be 22.5j plus 30k, and the unit for this moment is Newton meter. Does it stop there? No, you have to find the resultant moment. So similar with the force vector punya concept, if you want to find the resultant moment, you have to sum up the vector of moment 1 plus with moment 2. So moment 1 is 60I Newton meter and moment 2 is 22.5J plus 30K. I'll just rewrite this, and the corresponding vector for the resultant moment will be 60I plus 22.5J plus 30K, and the unit is Newton meter. Okay, dah siap.